Alright guys and girls, here is a review lesson on what we were talking about today is finding different area and perimeter questions for irregular shapes when you start combining triangles and trapezoids and rectangles and circles together. So a lot of these questions will have information on it, but you'll need to find extra information, and you won't really know what information you need to get until you get involved in the question. So let's take a look at this first one, and if the question was to find the area of the rocket ship drawing, that's all of this. That's all of this part, and that's all of this part. So really, we're just going to take the area of that rectangle, and we're going to add it to the area of the triangle. A little bit thinking backwards. We're going to just add those two together. But once we start looking at it, we've got to make sure we have enough information to do everything. So that's the first step, is making sure we have enough numbers to do what we want to do. So the first part is we want to do the area of the rectangle, and there's your length, and there's your width, so we can go ahead and get started on that. Area of a rectangle equals length times width, and that's 4 times 3. I do like brackets to show substitution, it's just me. And the units were meters, so it's 12 meters squared. And that's not bad. We'll just circle that and come back to it later. But now we want to do the area of the triangle. We know that the formula is base times height divided by 2. But what we have to say is look over on our triangle and see if we have the base and the height. On this part of the triangle, there's actually no number. And there's no number for the height right there. So we have to start looking and see where else on the sheet can we find that information. It's always going to be there. You just have to figure out where it is. Now hopefully you see the base of that triangle is going to be the same as this. The width of this rocket ship is still the same at the top, this part of the triangle. So this 3-meter base down here is still a 3-meter base right there. And now we just have to do the height. And now we have to look at our other. This shows that 4 meters goes from here to here. But the entire height is 7 meters. Now, when you look at that and think about it, what's left over from 7 meters minus 4 must be what's left from here to here. So we simply in our heads go 7 minus 4. The height here is 3 meters. If the height here is 3, the height there is going to be 3 meters. So our base and our height are both 3 meters. And now we can put it into our formula. It'll be 3 times 3 divided by 2. That's 9 divided by 2, and it equals 4.5 meters squared. Now remember the question, if we do go back to the question, was, what is the area of the entire rocket ship? Well, in order to find the area of the entire rocket ship, we have to add those two shapes together. So the area of the rectangle was 12 meters squared plus 4.5 meters squared equals 16.5 meters squared. There is how we do the first one. Now we did a couple like that in class today. So let's take a look at a little bit harder one. This gives us 2 questions to find. The area of the non-shaded figure, which would be this white area, and the perimeter of the shaded section, which is the blue triangle. So if we look at the area of the non-shaded figure, we have a big rectangle with a triangle pulled out of it. Because the triangle is the shaded figure, we're going to take that away. So really what we're going to be doing is finding the area of a rectangle and subtracting the area of the triangle. Because that's how we take that blue away. When we take it away, we're going to subtract. So we should have enough information to do our area of the rectangle. Area of a rectangle equals length times width, and that equals 60 times 30. What's my unit? Centimeters squared is the rectangle. Now I'm just going to move this out of my way. But now I have to do the triangle. Now if I look, I do have the base of the triangle and the height of the triangle. I'm good to go right here. So area, let me do it going in red. Area of the triangle is base times height divided by 2. the base is 30, the height is 30, we divide it by 2, 9,000 divided by 2 equals 4,500 meters squared. Hold on. Nope, I gotta backtrack. I was doing some math in my head. 30 times 30 is only 900. So it's 900 divided by 2, and that's 450. Looked a little bit big when I was doing it. Centimeters squared. And now remember, we're taking the 2 away from each other because we want to remove the blue from it. So it's really just 1,800 minus 450. We subtract. And that equals 1,350. Beautiful. Meters squared. That is what's left. That's the non-shaded figure. The next part it's really for my grade 8s. I'm going to erase this off the board here, so if you're following along, just hold on to it. I'm going to erase this off the board because this part was just for my grade 8s, but the grade 7s saw it, and they can do it. So anyhow, when it's asking for the perimeter of the shaded figure, that's the triangle, and we have 2 sides of the triangle with us. We have this one and this one, but we don't have this one. This would be a hard question, except we just finished our geometry unit doing Pythagorean theory, and that there is a right angle triangle. Hopefully, the grade 8s remember that Pythagorean theory. To find the hypotenuse of the right angle triangle, there's your formula. They will just put 30 squared plus 30 squared. That'll equal that. We already know that that's 900 plus 900 equals c squared. 1,800 is equal to c squared. And now when we want to find what just the hypotenuse is, we have to take the square root of 1,800. And it tells us that the length of that hypotenuse is 42.43. We'll put that over there on our picture. So when we're doing the perimeter of that triangle, we simply do P of the triangle equals side 1 plus side 2 plus side 3. And we get 30 plus 30 plus 42.43. And that equals 102.43 centimeters, because it is perimeter. So really a challenging question, but not so bad if we just came off our geometry unit and we just did all that work with Pythagorean theory. All right, next question. This one's more suited to the grade 7s, but the grade 8s can still look at it. Remember, when we're doing it, you got to see what information is missing. And in this one, this piece here is missing, and this piece here is missing, and this one here is missing. But they're all able to do it. This one's the easiest one over here, because the length from here to here is still going to be the same as from there to there. So it's just 2.3. No, it's not. It's 23. And now to figure out this one here, we have to take a look at what the whole length was versus what they've already used up. The whole length is 50, but we've used up 15 and 20, so that's 35. We subtract the two, whatever's remaining will give us what's left, and that will give you 15 centimeters. And the last one that's missing is this one right here. It's going to be 13 centimeters as well. Now when you're looking at that, and you see from here to here is 13, and from here to here, the whole thing is 23, so that would only leave 10 for this. You can see that this is not drawn to scale. I just pulled this off the internet so I get something quick, but I regret it because it's not to scale. So we're going to ignore the fact that it's not to scale. So if we were going to do this and we were going to find out the, let's call it area. The area of this shape, we're going to have to divide this into a few different sections. So that you could either go, there's 2 different ways, but let's just do it this way. We'll make a whole bunch of rectangles. For doing this one, area of a rectangle is still going to be length times width. That equals 15 and 23. And 15 times 23, let me just get into my calculator here, is 345 centimeters squared. This one and this one are the exact same size, so instead of doing it twice, let's just multiply it by 2. And 345 and 345 is 690 centimeters squared. So now you know 2 of them. Now we have to work on this one right here. We know that the distance from here to here is 20. We just have to figure out the distance from here to here. Again, you have to suspend the idea that this is not to scale. We know that the whole length from here to here, in this diagram, is 23, and from here to here is 13. Now that only leaves 10 centimeters for here. I apologize for the bad diagram, but I don't want to start this whole video again, so I'm just going to use it. So anyhow, if that is 10 from here to here, this will be 10. And we can go off and go ahead and do this rectangle. Area of a rectangle equals length times width equals 10 times 20. Oops, 10 times 20. Back that up. For a second. And that equals 200 centimeters squared. In order to find the area of the entire figure, we just add these two together. 690 and 200 is 890 centimeters squared. And that's your last one. This very last one is just for the grade 8s, because grade 7s won't be doing circles this year. So if I ask for the area of the non-shaded, I want these pieces right here, the white. We're going to have to do the area of both in order to get it. So the area of this square is interesting because it only gives us 20, and we can't be sure that it's a perfect square, but maybe we can. If we think that through, you see that the circle is touching all of the outside of this square, which means it's consistent all the way around. So the length at the top, this 20, is the same as that, is the same as that, is the same as that. So this is a square. So if we're going to get the area of a square, we know that it's side squared. It's 20 squared. It'll be 400 meters squared. But now we got to do the circle. The circle, we really need a radius or a diameter to get us started. And the picture doesn't have one. But again, you look for information on the page that might help you. We know that the distance from here to here is 20. And that's going to be the same as the distance from here to here. Therefore, the line going right across the middle of your circle, which is called the diameter, is 20. So we can go ahead and do the area of a circle because now we have enough information to proceed. We know the area of a circle is pi times radius squared. We need a radius, but we know that the diameter is 20, and the diameter is twice as big as the radius. So radius, therefore, must equal 10. It's half of the diameter. So 3.14 is what we use for pi, and we're going to have to put our radius in right there. Bedmas tells us to do the 10 squared first, so it's 3.14 times 100. And remember when we were multiplying by base 10 numbers or numbers with ones and zeros, all you're going to do, you're not reaching for your calculator here, you're just going to move that decimal place over 2 places. So it'll be 314 meters squared. So now you have these two numbers, 400 and 314. And remember what was asked. It asked us for the area of the unshaded portion, which means we have to take the circle out. And if we take the circle out, what we are doing is subtraction. So it will simply be 400 minus 314, and that is 86 meters squared. I'm not going to worry about the circumference of a circle because this video is long enough. All right, good luck with that.